Hello friends, I am Chandan. This is my handwritten notes for GATE EAC SSC ISRO DRDO BARC. The PDF link is given on the description. You can download it. Let's try to understand what is reversible process. A reversible process, uh, suppose suppose focus on that. There is a graph is there, and this is the initial state. This is the initial state, and initial state means any condition of the system known as state. Okay, and in this system there is a measurable properties. Suppose pressure is the measurable properties, temperature is there, and volume is there. This is the measurable properties of the system. Now suppose this state 1 is changing to state 2 by following the same path. So this change is changing to state 2 by following this path, and when it's going to state 2, the pressure is suppose P2, temperature T2, and its volume may be V2. But if this state is changing from state 2 to state 1 by following the same path, there is no effect on the system and surrounding, then it is known as reversible process. Suppose example, suppose in this process 1 to 2, when suppose there is a work transfer that is minus 10 kilojoule and heat transfer that is plus 5 kilojoule for process 1 to 2, and if the process is going back to process 2 to process 1, process 2 to state 2 to state 1, the work is suppose plus 10 kilojoule and heat transfer that is minus 5 kilojoule, just opposite sign. Here there is just opposite sign, then this is known as reversible process. Let's try to understand what is this. So a process is said to be a reversible process when it is reversed by following the same path. There is no effect on the system and surrounding. Now frictionless quasi-static process are reversible process. So in process, if any process, if there is and no friction is there, then this is known as quasi-static process, and there is this is known as reversible process. And quasi-static process means that is very slow process. Now the process in which the process which is not reversible is an irreversible process. Which is not reversible is an irreversible process. The practical all the practical process except natural process, that is condensation, evaporation, are irreversible process, and friction is one of the reason to make the process irreversible. So the friction is one of the reason to the make the process is irreversible, and reversible process are most efficient process. When you read the Carnot cycle or any cycle, so when you focus, when you see that the reversible process is the most efficient process, and reversible process are used to compare other practical process. Okay, when you calculate the efficiency or COP of any refrigeration or heat pump, we always compare the reversible process, how much efficient it is. We always compare. So reversible process are the most efficient process because there is no friction is there. So that is why this is most efficient process, and reversible process are used to compare the other practical process. So this is all about reversible process and irreversible process. Now next topic, that is Gibbs phase rule. Gibbs phase rule say that F plus P that is equal to C plus N. What is F? F is the degree of freedom, and P is the number of phase, C is the number of chemical composition, and N is the number of non-composition variable. Now here, so what is understand? First try to understand what is degree of freedom. The degree of freedom is the number of independent variable required or intensive property required to define the state of the system is known as degree of freedom. Now intensive properties mean independent of mass. Properties means any measurable characteristic of the system is known as property. So intensive properties mean independent of mass or volume. So the number of, what is degree of freedom? The number of independent variable required or intensive property required to define the state of the system. So this is known as degree of freedom. The formula of degree of freedom, that is A plus P, that is equal to C plus N. In thermodynamics, the pressure and temperature during phase change, the pressure and temperature is not changed. That is why N equal to 2. So the final formula is that A plus P, that is equal to C plus 2. So in thermodynamics, when anyone say that what is Gibbs phase rule, you have to tell that A plus P, that is equal to C plus 2. So this is very, very important. So here that means why C plus 2, why it is 2? The phase change but pressure and temperature is not change, so that is why N equal to 2. Okay, so this is the Gibbs phase rule for thermodynamics. Now there is an example. Let's try to calculate the degree of freedom of a gas container. Suppose this is the this is the container, and in this container there is a gas is there, oxygen is there. Here there is a oxygen is there. Oxygen is in gaseous state. So let's try to understand what is degree of freedom of this system. So we know that the formula A plus P, that is equal to C plus 2. So C plus 2 is due to the pressure and temperature. So that is why C plus 2. Now F, we have to calculate the value F, degree of freedom. A plus P, number of phase. We know that there is 3 phases exist, that is solid phase, liquid phase and gaseous phase. So in this system there is only the gaseous phase. So that is why P is equal to 1. So A plus P, that is P value 1, that is equal to C. What is the C? What is the number of chemical composition? Then here only oxygen is there, though there is no other element is there. So that is why the degree of freedom, if you calculate the degree of freedom, that is F equal to 2. Okay, now focus on another example. Suppose this is another container. In this container there is a steam is there and there is a water is there. Steam, the chemical composition H2O, and water have the chemical composition H2O. Thus what is the value of C? Then C equal to 1. And here there is a 2 phases there is liquid phase and gaseous phase. So that is why if you calculate the degree of freedom, A plus P, that is equal to C plus 2. A plus P, what is the number of phases? That is 2 because of liquid and water. And C composition, number of chemical composition, that is only H2 is there, and C plus 2. So if you calculate the degree of freedom, that is equal to 1. Now there is another container. In this container there is steam, ice and water is there. Steam has the same chemical composition, ice have the same chemical composition, and water have the same H, that means H2O, and there is 3 phases there. So if we calculate the degree of freedom, A plus P, that is C plus 2. So F plus P, number of phases, that is 3. So this is 3. C chemical composition, that is 1. C plus 2. So if we calculate that, then calculate degree of freedom, that is equal to 0. So this is very, very important. That means here degree of freedom is 0. So here you can say that the steam, ice and water coexist at a particular point. This particular point is known as triple point. So remember this data. This is very, very important when you read the last chapter, that is properties of pure systems. You can understand this triple point. Let's remember this data. Triple point, that is triple point pressure. That triple point means the solid, liquid and vapor are coexist at a particular point. So this is known as triple point. So here remember this data, that is pressure, that is 611 Pascal and temperature 0.01 degrees Celsius. This is very, very important. And in this triple point the degree of freedom is equal to 0. Now there is another concept, that is critical point concept is there. There in property of pure systems, you understand that. Just try to understand the basic things. There is a TH diagram, temperature entropy diagram, specific entropy diagram, and this is the vapor dome. Okay, this is the vapor dome. Suppose here there is a water. You have some water on a beaker, and the water is 30 degrees Celsius temperature. We apply, suppose there is a water and the initial temperature of the water, that is 20 degrees Celsius. You apply heat, and the aim of this water, you want to get steam at 150 degrees Celsius temperature. So you have to apply some heat up to 100 degrees Celsius temperature of water. After that, you have to supply the latent heat, and again you have to apply the sensible heat to get 150 degrees Celsius temperature. So if uh, if here, if we see, this is the liquid region, this is the liquid region, and this is the liquid plus vapor region, and this is the vapor region, and this is the vapor dome. Here, this is the vapor dome, and here, this is the upper point is known as critical point, and this curve is known as saturation liquid curve, and this curve is known as saturation vapor curve. And this is the critical point. Remember this data, just remember this data. Critical point temperature, that is 374 degrees Celsius, and critical point pressure, that is 218 to 222 bar. Just remember this data. This is very important. This is very important. That critical point means when liquid is directly converted to vapor. This is known as critical point. Okay, so here the liquid is directly converted to vapor. Here there is a liquid phase, and this is a vapor state. Here the liquid directly converted to vapor. Okay, so this is known as critical point. Just remember the data, that is critical point, that is 374 degrees Celsius, and critical point pressure, that is 218 to 222 bar. Now let's try to understand pure substance. Pure substance. According to this, according to thermodynamics, all the process, all the substance which are homogeneous in chemical composition and aggregation, that means bonding, known as pure substance. So the example of pure substance is Ag, Au, gold, copper, H2O, CO2, alcohol plus water, salt plus water, pure air, mixture of refrigerant, that is mixture of refrigerant are known as azeotropic substance. So mixture of refrigerant is like a pure substance. Okay, so what is pure substance? All the substance which are homogeneous in chemical composition and aggregation, that is bonding, are known as properties, that is pure substance. It may be pure substance or it may be mixture. It may be pure substance or it may be mixture. So here moist air is not the pure substance. Remember this data, that is moist air are not the pure substance. Now if you see the classification, suppose there is a matter have pure substance and mixture. These two are pure substance. It may be pure substance, it may be mixture. Now pure substance, that is element, that is Ag, Au, copper, this is a single element is there, and there is a compound element, combination of two element, that is H2O, CO2 is there. Now if there is a mixture is there, mixture means it may be homogeneous mixture, it may be heterogeneous mixture. Homogeneous mixture means homogeneous throughout or uniform property throughout. Example is water plus sugar, alcohol plus water, and salt plus water. So this is the example of pure substance. Okay, so this is all of the basic concept. We completed the 4 lecture on basic concept of thermodynamics. I cover that in first chapter we understand the thermodynamics. Total in 4 chapter we understand, in 4 lecture we understand that what is thermodynamics, what is system, what is surrounding, what is boundary, types of system, properties of system, that is property of system, that is intensive property, extensive property, specific quantities is there, important point with respect to property, microscopic and macroscopic approach of thermodynamics. In microscopic approach, there is a statistical approach is there, and macroscopic classical approach is there. And now we understand that what is principle of continuum, and there is a state of the system, thermodynamic equilibrium, quasi-static process, reversible and irreversible process, Gibbs phase rule, properties of pure substance, and pure substance, what is pure substance, classification, and pure substance according to the thermodynamics. So all about we understand that in these 4 lecture. Okay, thank you.